Welcome to another exercise for the workbook Statistics. This time I'm going to talk about how to calculate measures of dispersion for unclassified data sets. So here our task is the points achieved by the pupils of a particular class are distributed as follows. Now we get this data set with a total of 9 different results. And we have 4 tasks to perform. First off, calculate the range of the data set. Then calculate the interquartile range. Determine the corrected variance. And finally, based on this, determine the corrected standard deviation. Well, before we start, even with part A, the first thing I'm going to do is just ordering or reordering my data set. So I'm going to copy this data set. Then I'm going to arrange this in an ascending fashion. So I'm starting with the smallest value and always increasing in the values until I arrived at the largest data point. Because now I can use this to easily calculate the range and the interquartile distance. For the range, which is actually part A, I have simply maximum minus minimum. Or, if I want to understand what this is about, I can think about a box plot. There, the range is nothing else than the distance between lower and upper whisker. Well, maximum, minimum, in this case, are just last and first value in this ordered data set. So here, it's the 100 and the 6. So I have 100 minus 6, giving me 94 as a range. And that's already part A. For part B, I'm using the same ordered data set, and I'm going for the interquartile range. Again, thinking about the box plot, that's more or less the height of my box of the box plot. So how do I get this? Here I'm going to use first and third quartile, or in other words, the 75% percentile and the 25% percentile. How do I calculate those? Well, in the first step, I'm going to multiply 0.75 with the number of observations, which is 9. Then I'm going to multiply for this one the 0.25 with 9 observations, giving me as a result 6.75, 2.25. And now the important part is I have 2 different formulas for these quantiles, quartiles, percentiles, whatever. And they depend on whether the result I get is an integer or not. In this case, it's not an integer. So what I'm going to do is simply round up both of them. And here it doesn't matter what the values after the decimal are. If they are not 0, I'm always rounding up. So here I get 7 and here I get 3. Even though normally I would round this down, but I'm going to round up in either case. Well, this yields me 7 and 3, so I'm looking up the 7th and the 3rd value, which here is the 87 and the 53. I'm going to subtract the 3rd from the 7th value, giving me an end result of 34, which in this case is the height of the box of my box plot or my interquartile range. Well, that was already part B. So let's continue with our part C. And in C, we're talking about the variance. The variance here, well, I'm going to use the same ordered data set, but I no longer actually need the ordered data set. I could also use the unordered one. But before I can start with the variance, I first need the arithmetic mean. Well, for incorrect or for unordered, unclassified data, I can simply add up all my values and divide them by the number of observations. That's what I'm going to do here. 9 observations, adding up all of the observations, dividing by 9, gives me in the end 65.6667 as the arithmetic mean. This I'm going to use in the real calculation of the variance, for which I'm going to use this formula. The first part is actually similar to the arithmetic mean. I have here this sum, which just describes I'm going to add up again all observations, but now I'm using the squared observations. That's all the squared observations. adding them up, dividing them by n minus 1, so the number of observations minus 1, so in this case 8. And I'm subtracting from this the arithmetic mean squared. So I'm using this value to the power of 2, and I multiply this with a correction factor, which is n divided by n minus 1. Actually, what I have here, this first part usually would be 1 divided by n and this one, and I would have neither that correction factor nor that one if I work with the uncorrected variance. Since I have the corrected variance, which was asked here, I have to use this part and that part to correct for, well, my errors in the sample. So I'm going to do what I just said. I'm going to sum up all the squared observations. That's this part here. And I'm going to divide this by the number of observations minus 1. That's the 8 here. I'm going to subtract n divided by n minus 1, so 9 divided by 8, times the arithmetic mean to the power of 2. That's this part here. If I put this into the calculator, yields me a final result of 870.9951. Well, that's already part C, that's my corrected variance. To actually make a bit more sense out of this, because it's pretty hard to just describe what the variance actually is and what it can be used for, we're instead going to calculate the standard deviation. But once we have this variance, it's actually pretty straightforward and easy to get the standard deviation. Because for the standard deviation, we're just going to take the variance we have from C, and we're going to take the square root thereof. So square root of this 870 something yields me in the end 29.5126. So that's it about the standard deviation. Just take the square root of the variance. If I have the corrected variance, I will also get the corrected standard deviation. If I were to work with the uncorrected variance, I will also get the uncorrected standard deviation. So if those two are supposed to be different, then I have to take care to, well, correct one of them, but not the other. If they could be different, or should, if they could be the same or should be the same as is the case here, then you can simply copy paste the variance from the previous exercise part. And usually it's the case that in the first part you need to calculate the variance, and then build on this, you calculate the standard deviation. Well, this concludes this exercise. So I hope you enjoyed it. I say goodbye and see you next time.